Howdy folks, I recently picked up this Hioki megaohm meter at a thrift store, and this is model, for those following along, it is 3110-05. It is a transistorized insulation tester. It sounds kind of fancy. It really, of course, it isn't. This is just a 1 kilovolt, as it says here, 1 kilovolt, 2 gigohm analog movement here. And it's really, it even says it's only really good for 2 meg to 1 gig. And it's 5% accurate. It's not, it's nothing special, but it's a battery powered portable meter. And I didn't really need this because I already got sort of an Amazon special that has equivalent specs. I just thought this was kind of neat, and I've got like a properly certified mains tester that goes up to 5 kV for doing real work. But I like this because I thought this was kind of neat and it was cheap. And there's a couple interesting things about this. I'll go over this just a little bit and then get on to what I think is most interesting. The date is 1987, so that was when this was manufactured, and it's battery powered by eight AA batteries, which is kind of ridiculous. They've got all the instructions on the back, everything you could ever need, made in Japan. They actually have the manual for this still on their website, which is kind of great. And the top is where your connections come in, and I do have the probes with it. So the earth connection is basically just an alligator clip, and of course insulated for your protection. And then the what they call the line is actually the probe, and it's just this little like metal probe. It's not very sharp or anything, and it just has this little I don't know. It's spring loaded in there. It's just a plate basically, nothing really special. You just do a quarter turn and it locks it in there. There is a DC in if you don't want to use 8 batteries, guard terminal, and then a little battery check, which is actually just screw heads. And so according to the instructions, what you do is you take the probe and you just touch it to the screw head, and if the needle is in this B mark here, then the batteries are good and ready for test. And so as you can see, right from the time I got it, the first thing I did was I tested it, and they see it's good. It's kind of heavy, so there's obviously batteries in here already that were in it when I bought it. So and you can also tell that it's working by if you actually press the button to run it. It's literally just a single button. You might be able to hear the high frequency of the high voltage generator, and if you don't want to hold it down, it actually just flips up like that. And I like how there's a red card underneath that shows so that you know that it's energized. I think that's it. It's really simple. It's a 1-button device, but it's quite well done. There's a little adjustment for the meter, but nothing was needed there. And it's not super accurate, but whatever. So anyway, it came with batteries. So the first thing obviously I wanted to do was just verify that they're not leaking or anything like that, because that's the worst thing. I've had that happen too many times. So I just take the cover off, and it's got these 2 little packs of 8 cells each, which is kind of nice. And they're all the same, which is great. And you take them out, and then you start noticing things are a little interesting. So these are Toshiba cells, and the most obvious thing is that they are all in Japanese. And that's, of course, you can't really get Japanese language batteries here. And they're also quite old style. And if you actually look at what is on the bottom of these cells, it is stamped 87-07. And that is a manufacturing date of 1987, which happens to correspond with the 1987 this meter was manufactured, which was, of course, Japan. These are Japanese batteries. So all the signs point to these being the original batteries the unit shipped with right from the factory, which I think is pretty cool. I cannot think of any other product that I have that has older batteries in it. So these would be, as of now, they would be 38 years old, and they are still working. So every single one of these cells is above 1.5 volts. So as far as voltage goes, they are all still perfect. None of them have leaked. None of them have, they're cosmetically perfect. And I know what you're saying. Well, the internal resistance is probably terrible. And that's true. Obviously, these are carbon zinc cells, and their internal resistance goes up as they get older. So they're definitely not. They're not going to be perfect. But this is a low enough, or should I say, this is a high enough impedance device that it doesn't care, and it still works perfectly within spec with these batteries in it. So leave it in the comments if you found anything that that if you have batteries for a device that are older than 38 years and are still functioning in that device. That's, I think I just find that to be really quite impressive. So I think the next thing we should do is, just to satisfy people's curiosity, is open this up. I don't think there's going to be anything special in here. I bet it's going to be a little switch mode supply, not even switch mode supply. It's just going to be a little boost converter and some resistors. There's probably nothing more in there, but I'll take the screws out and I'll bring you back when I'm done. And here it is, all the screws removed, and that should be it, just to open it all up. And I suspect there's going to be some wires, and there are. But this is about what I expected. So, I mean, it's well made. You can see we've got, threaded inserts into the plastic, even for stuff you're really not supposed to take apart. We've got our meter movement, which is all one piece in there. So obviously I'm not going to touch any of that. And then we've got our single-sided board, which you can tell is hand laid out because all the traces are hand drawn. And yeah, it's about exactly what you'd expect. We've got our switch here, which is literally just it's not even a real component. It's something that they've just made out of some custom plastic pieces with a little metal leaf in there. And yeah, it's kind of exactly what you'd expect. It's probably got an oscillator which drives this transformer, which is nicely labeled 1000 volts. Some trimmers for this thing being fully manually calibrated. A big resistor for protection on the output there, just to limit the current, and that's about it. It's got one electrolytic capacitor, which I'm not even going to bother to touch, and that's it. Yeah, it's it's a very low end instrument, but it's well made low end instrument. So anyway, yeah, that's it. I think the instrument is honestly not as interesting as the batteries that it came with, and I have no intention of removing these batteries. I'm going to just keep them in here, and I'll keep using the thing, and yeah, God knows how long these things are going to last. The fact that they haven't failed at this point, if they're kept in a good climate controlled environment, they could go for quite a bit longer. Obviously whatever's in here is very stable. Carbon zinc stuff is relatively stable. Although when it gets depleted, they do tend to leak quite easily, just like alkalines do. But really only when they're depleted. So as long as they have voltage in them, they're usually pretty good, from my experience. But anyway, yeah, thought that was cool. So anyway, till next time, thanks for watching.